Now, it says here for compound interest, exponential growth functions are used in real-life situations involving compound interest. Compound interest is interest paid on the initial investment, called the principal, and on previously earned interest. Interest is frequently compounded more than once a year. Therefore, a formula must be modified. And this might be a formula that you're more familiar with. You can see how A is the amount you have after some time t. P is the initial amount, the principal amount that you start with. We still have 1 plus r, only this time r will be divided by the number of times you expect to compound in 1 year. So the words like monthly, or weekly, or daily will determine the value of n. For weekly, it would be 52. For monthly, it would be 12. For daily, we will use 365. There are other words out there that will determine the value of n as well, so hopefully you can look them up in a dictionary when you come across them, and you'll know what the number should be. We have all the variables listed for you here to the right, and let's see if we can apply this to a situation. Whenever you have a word problem, it's always a good idea to list the given information. So if you deposit $1,500, that's your principal. And you deposit that into an account that pays 6% annual interest. So that's your rate, 0.06. Find the balance after 2 years. So t equals 2. If the interest is compounded, for part A, it says annually. So n equals 1. For part B, it says semi-annually. Okay, so that's going to be n equals 2. For part C, it says quarterly, so n equals 4. These are new vocabulary words. If you don't already know what they mean, you got to look them up in the dictionary or ask a friend. And then for, let's call this D. And then for D, daily is when n equals 365. So the only variable that's changing its value is the value of n. The other three variables are fixed. So let's put it into the formula. We're going to find out what A is when the principal amount is $1,500. We're going to have 1 plus the rate of 0.06 and over n, raised to the n times t, which in this case is 2. So for A, n is 1. For B, please write this in. For B, n is 2, so put a 2 down here and a 2 up here. For C, n is 4, so put a 4 down here and a 4 up here. And finally D, where do I have room? A equals 1,500 times 1 plus 0.06 over 365 raised to 365 times 2. Okay? And at this point, it's just the task of typing into your calculator. If you want to simplify things so you have less to type into your calculator, I'd highly recommend writing it with the growth factor value. So this becomes 1.06, and that's 1 times 2, which is just 2. This one, you're going to have 0.06 divided by 2, and that becomes 0.03. So that's going to be 1.03 raised to the 4th. For this one, let's see. 0.06 divided by 4 is 0.015, so this becomes 1.015, and that's raised to the 4 times 2, which is 8. And finally this one, you're going to have 1,500. And you know what? I might just leave it like that. 1 plus 0.06 over 365. Now, 365 times 2 is 730. Okay? So now using your calculator, and this will be off camera for now, 1,500 times 1.06 raised to the second, and that's going to produce, and this is actually equal, this is not rounded, to $1,685.40. The next one, this one I am going to round, so it's going to be approximately equal to $1,688.26. Let's see. Part C. I'm getting a dollar amount that is equal to $1,689.74. I had to round that up to 74. It is approximately equal to, thank you. And then D, this is going to be raised, I'm sorry, 1,500 times the left parenthesis of 1 plus 0.06 divided by 365, close parentheses, raised is 730. And this is also going to be rounded, so it's approximately equal to $1,691.23. Now, since this is only occurring over 2 years, you're not seeing much of an increase, even though the number of times you compound it in 1 year has increased significantly. It's really the length of time left in the account that earns the money for you, okay, over several years. Over a 2-year period, not much is going to happen. Okay, so we went from starting with $1,500 to compounding it daily and getting all the way up to $1,691.23. This is having your money make money for you.